Hello. In the Python programming course, we are currently discussing module 2. We had covered functions, modules, file handling in previous sessions, and we are currently talking about exception handling. In the previous video, we had discussed what do you mean by an exception, what is exception handling mechanism. Then we had seen some of the demo programs to understand the importance of having exception handling. Then we had also seen what are the different built-in exceptions available in Python. Then we discussed how to handle exceptions using the keywords like try, except, finally and raise. Then we had seen the syntax of try and except statement. Some of the programs also we had discussed. Then we also talked about how the except class can be used with no exception and with multiple exceptions also. We can define as many exception blocks as we want in the try block, in the try and except block. So in all our earlier examples itself, we had seen how we can have more than one except block. So if you have the except block in the exception handling mechanism, you can observe here I am having index error. I have a tuple defined. I try to print x of 6, where 6 is not an index specified in the tuple. So obviously it has given you this particular error. Apart from the index error, if any other exception happened in this particular code segment, it will go to the common error, right? So this also we discussed in our previous session. Now we had also seen the except clause can be used with multiple exceptions in one except statement or in more than one except statement. So one way of handling multiple exceptions is this way, which we had seen in our previous video. I'm having a tuple and I'm assigning a string value to the variable a, and I try printing the third element of the tuple, and I try dividing x of 2 by 10, and I try dividing the string by 2. So when I divide it by 2, obviously it will go into the type error. So that is why I am getting this particular output, right? So here in this particular block, the possible errors that may happen will be index error, type error. As I do division operation, zero division error also may occur. So what I have done, I have handled 3 different exceptions using 3 different except statements. Okay, so this is one way of handling multiple exceptions. Apart from that, you can also have multiple exceptions in a single except block itself. So let us see how multiple exceptions can be handled in a single except block. Okay, so this is the program we had seen. Okay, so here what we are going to do, I am having separate except statement for each and every error. When I try executing this, I am not having any error. You can observe this particular try block. I print x of 3, I print x of 2 by 10, and I am adding the string 100 with string 2. So I get 1002. Right? So obviously these except blocks will be ignored, and it will print this particular statement because it goes into the else block as there is no error in my program. Okay, now if at all I'm going to use this integer, right? I try to add an integer and a string. I run the program and it shows type error. It shows type error. You can observe this is the type error. It is not an index error, so it goes to the next except block. It is a type error, and as it is the type error, I get this particular message in the output. Okay, now what I'm going to do, instead of having all these except blocks separately, suppose you are not going to specify any error message this way, you just want to display a simple error message to the user. You don't want to elaborate on that particular error message. In those cases, instead of having separate except block, what you can do, you can have all the errors specified here itself, which is separated by comma and enclosed in parenthesis. I am going to specify all the errors here, and I just say specific error occurred, and I'm going to ignore all these errors. So what I did, I have exempted separate except blocks. Instead, I specified all the errors in a single except block itself, and I just print the message. And apart from these three errors, if you have any other exception, it will go to this particular common error. If you don't have any error, it will go into the else block, right? So as of now, I'm having this particular exception which may be raised in my program. During the execution, I clear the console, I execute it, and you can see it says specific error occurred. It says specific error occurred. The error happened is actually the type error, right? It is the type error. So there is no error in this particular statement, there is no error here, and the only error happened is here. Why? Because integer and a string cannot be added, so it gives you type error. Suppose, say for example, I give it as the correct statement. Alright, I am having a also an string, and this is also a string, so obviously it will not have any error, right? So it's not having any error. It says completed without any error. Okay, I clear the console, and suppose, say for example, you try to divide by 0. You try to divide by 0, then this particular error will be raised. So for this also, this particular except block will be executed. So when I run, you can observe x of 3 is 4, so that is printed here. Then the next statement is x of 2 divided by 0, so which is a 0 division error that happened to be this particular block, and this message will be displayed to the user, right? So here you are going to simply give a layman message to the user, and you are not going to elaborate on that particular error. So if these three errors happen, this particular block will be executed. So this is another way of handling multiple exceptions, where multiple exceptions can be given in a separate except block, or you can have a single except statement with multiple exceptions specified. This is also allowed. Okay, so that is what we had seen as the demo program in Spider 3. This was the program we had seen, another way of handling multiple exceptions, right? So you try adding there in the example. So here in the example, I try to divide the string by 2, so obviously I got the type error, so I get specific error occurred. Okay, So this is the method of handling multiple exceptions. Okay. Next, let us see how try and finally blocks can be specified in a Python program. So as finally block is used for executing set of statements regardless of the try block raises an error or not. It is very much similar to the finally blocks of C++ and Java program. Okay, so the finally block, if it is specified, so that means finally block is not mandatory, it is optional. If it is specified, it will be executed regardless if the try block raises an error or not. Okay, let's see an example. So this is case 1. What it says, the finally block will be executed if an exception is raised or exception is not raised. Okay, so with exception also finally block will be executed, without exception also the finally block will be executed. Okay, so let us see an example here. I have same set of statements, and here I try to divide the string. A is a string. I try to divide the string by 2, so obviously it will raise a type error. Okay, the specific error will be occurring. Now after this error happened, it is not going to this except block, it will not go to the else block, but it goes to the finally block, and this message was displayed, okay, in the output. So what happened? The try block will be executed. If an exception is raised, the corresponding except block will be executed. After executing the except block, it goes to the finally block if there is an exception. Whereas in case 2, I had shown you without exception. If exception is not raised, even then the finally block will be executed. So what you do here, the same set of statements, instead of having a divided by 2, I am going to add the string a with another string 2. So there is no error in the try block. So what happened now? It will not execute this except block. It will not execute this except block. It executes the else block. It executes the else block. If you observe the output, you can understand. It executes the else block, then it executes the finally block also. So this example clearly proves that the finally block will be executed whether there is an exception raised or not. So that is why generally the finally block will be used to close a file or to close a database connection, etc. So whenever you want to do some housekeeping task, those tasks can be put in the finally block, so that automatically whether there is an exception raised or not, the finally block will help you in closing a file or in closing a database connection. So let us see a demo program. I am going to take another demo program. So this is a very simple demo program that shows how the finally block helps you in closing the file. Okay. Now, so this try block will raise an error when trying to write to a read only file. Okay, you can observe the set of statements. I have 2 try blocks, so you can also understand try blocks can be nested. You can have nesting of try and except blocks. This is also allowed. Okay, so what I do here, I am trying to open a file. I am trying to open a file, and you can observe the file is opened in the read mode. Then here I try to write something into the file. We had already discussed in the file handling how to open a file, how to write a content to a file, and how to open it in different modes. All those things we had already discussed. So here what I do, I'm going to write something into the file where file writing is not allowed, because I'm opening the file in a read only mode. Okay, so if any error happens, I say something went wrong when writing to the file. And you can observe here I am using a finally block to close the file. So whether there is an exception or not, I am trying to close the file after the execution. Okay, and in the same way I try to open. While opening, if I have any error, then it will say something went wrong when opening the file. So let us see what happens. I clear the console now. I try to open it in the read mode. I'm going to execute the file, and it says something went wrong when writing to the file. Something went wrong while writing to the file. And if you want, you can have a print statement here that says file is, yeah. So rather than having it here, I can have it here. Okay, so you close the file and you ask the program to print the message. Okay, so let us run the program here, and it says something went wrong when writing to the file. That means this except block is executed. Why? Because I opened a file in the read mode and then I tried to write something which is not possible. So obviously it raises an exception. When after raising the exception, it is caught in this except block, and it says something went wrong when writing to the file. Okay, and in the finally block, I am closing the file, then this particular statement is executed, so I get this particular message. Okay, now I'm not going to raise an exception, right? So I am going to open it in the write mode itself. I open it in the write mode. So when you open it in the write mode, obviously it is not going to have any error while trying to write to this particular file. So now I'm going to execute this program. So this part you can omit, right? Because I'm trying to open it in the write mode. I clear the console, I execute it, and it executes this and it executes this also. Okay, then it says there is no error. So if you want, we can see the Python programs. Inside the Python programs, I have the demo file. This is the file name, demo file new. Let us try opening this file. When I open this file, I get the message hello world. It's as simple as that. So you get this message written. So after writing this message, since there is no exception, this block is not executed. It goes to the finally block and the file is closed. Okay, now let us try whether this particular statement is executed. If I try to open a file which is not available, so let me change the name, new one, and I try opening it. Let me try opening it, because this particular file does not exist, and I'm going to open it in the read mode. I open it in the read mode. It says something went wrong when opening the file. So these set of statements are ignored. Why? Because while trying to open this file itself, an error was raised, or an exception was raised. So it goes to this particular except block and it prints something went wrong when opening the file, because this file does not exist. Okay, so this is how the finally block helps in closing the file. So whether an exception is raised or not, the finally block will be executed. So that is the purpose of having finally block. Then another very interesting thing that we have to understand is the exception with arguments. Okay, so in all the earlier examples we just receive or catch the exceptions of a particular type and we print our own message, right? Apart from that, if you want to have some additional information about these exceptions, if you want to have additional information about these exceptions, we can use exception with arguments. So it is possible to have exception with arguments. An argument is a value that gives additional information about the problem or the error or the exception that is raised. So it receives single or multiple values in the form of a tuple, and this tuple contains an error string, an error number and an error location. Okay, so you are going to just use a variable argument or any other variable for that matter. So this variable will receive single value or multiple values in the form of tuple, and it will be containing the error string, number and location. Okay, so this is a very simple example we have for the exception with argument. You can observe here I use a try block and I have x value with 100, y value with 10, and I try dividing it, and I am going to print the value of a. And in the except block I am going to have 0 division error. Then I am giving a variable here arg. So this is the variable which receives multiple values or a single value that gives the additional information of this particular error. So what happens now, when I print, this will be displayed. Along with that, what is the additional information available, that will also be displayed. And as usual, if there is no exception, this particular message is to be displayed. Okay, so here in this particular code segment I don't have an error, because 100 divided by 10 will be perfectly divided by the Python program, and it will be printing the result as 10. And since there is no error, the else block is executed, so I get the message no error. On the other hand, the same code is modified with y value as 0. So when I try to divide it, obviously 0 division error happens, and I give the argument also which catches the additional information about the 0 division error. And if you see the output, the error is the message that you have given. So that is given, and the argument have this value. 0 division error, integer division or modulo by 0. So this is the additional information which is already stored in the because 0 division error is a built-in exception, right? So in the built-in exception itself, the error message is also stored. So that error message is now received by this particular argument. And probably you may not have this argument working in 3.6 version, please try that, but this one I have tried in 2.7 version of Python program, right? So the only thing is, if you give an argument along with an exception, a built-in exception or a user defined exception, the additional information about that error will be captured in this particular variable. That is the advantage of having exception with arguments. So with that, all the built-in exceptions and how to handle the exceptions have been covered. The next topic that we are going to discuss will be the user defined exception, right? So how you can create your own exception object, then how it can be raised in a try block, and how it can be caught in the except block. So suppose, say for example, you want to have an exception to be raised whenever the x value, right? So variable x value is not between 0 to 100. You want the x value to be 0 to 100. If the value is not between 0 to 100, you want to raise your own exception. So that particular exception is not a predefined exception, but you want to have it as a predefined exception. In that case, we can define our own exception class, and an object of that particular class can be created and raised in a Python program. So let us see how the user defined exceptions are declared and how it can be used in a Python program in the next session. Thank you.